So let's continue. Let's start collecting ground control points. You already know it from the lecture. So what are ground control points and where do you need them for? So I already wrote an answer here. So these are reference points which can be recognized in both images, locations, objects, and related to each other. So ground control points are those points which can help, which helps us to reference the slave map to the master map, and using these points, locations of points, in our case in slave map, the ArcGIS measures the inner location measured in columns and pixels, and it relates the inner point, the inner locations of pixels to the outer locations of the master map, which has the coordinate system, and thus we just reference our slave map to the coordinate system of a master map. And the next question is, what are the residuals and how they are calculated? So if you're familiar with the statistics, I think you already know about the answer to this question, but in case you do not familiar, I just advise you to make more research in the internet about residuals. But here is some information I put here. So in statistics and optimization, errors and residuals are two closely related and easily confused measures of the deviation of an observed value of an element of the statistical sample from its theoretical value. The error of an observed value is the deviation of the observed value from the true value of a quantity of interest. For example, a population mean, and the residual of an observed value is the difference between the observed value and the estimated value of the quantity of interest. For example, a sample mean. So a residual, in other words, is error. So it's the deviation from the true location of a point, or the difference between the location we measured from a true location of this point in a coordinate system. So it happens why we need this information, because while we start to collect ground control points, there will be slight distortions, and the accuracy of your georeferencing will depend on the how you directly, closely and accurately and precisely find control points and reference this point to or find the same location, the same location on your master map. And the bigger the deviation, the bigger the residual from the observed and true locations of the point, the higher the root mean square error, which is the sum of all residuals, and less accurate your georeferencing result. So let's start collecting control points. So while collecting, at first we will collect 2 control points and 10, and at the end we will collect 12 control points. And while we're collecting control points, we'll answer to these questions. So how we collect ground control points? At first, you should open the georeferencing tool package. In case you don't have it in your menu box, I will just you should just right click button on the menu box, and here we can just activate georeferencing. In my case, it's activated. So here is our tools of which belongs to georeferencing, and this is a basic tool, add control points, which we will use during our tutorial. So at first we should starting to recognize the same locations, the same objects and places in both images. In our case, we can see here the cross of the roads, right? The center of the cross of the roads. And let's try to find the same place in our master map. Zoom to layer. And here I see that here is the same locations across all the rows and the center. So at first, let's zoom to light again to the slave map. So we will reference slave map, which is a raster image and do not have the coordinate system, to the master map. And we will connect this slave map to the master map via ground control points, which we should recognize with our eyes and measure it manually. So let's start at control point. So first I zoom in, and here I just here I note the center of the cross. See, so the first ground control point is taken. It's colored with green, right, color, and I go to my table of contents, master map, and right click button and zoom to layer. And again I find the same place. I zoom in, I try to find the same location, the center. So the higher the scale of the image of your map you use, more accurate and precise your georeferencing will have, and the less residuals we will achieve. So let's measure. So see, it's with red color, right? So when I note the point in slave map, it's colored with green, and when I note it in a master map, it's colored with red. So the first ground control point is taken. So see, ArcGIS already started to reference and overlay my slave map to the master map. And let's open and let's measure the second ground control point. I can do it, for instance, I see here water. I just take this place and I close slave map for a while, and I zoom out again. I think this one, right? The same place. Let's open. So see that the overlay now is more correct and accurate. So at first, so we measured already 2 ground control points, and here is the answer. You have points. Answer the exercises. Note that during the collection, the farm map is adjusted based on the transformation to match the reference dataset after each collection point. So do not forget to distribute your ground control points across the map. So you should try to find ground and note the control points across all your maps, so it should be spatially distributed. Do not try to search ground control points close to each other, because this will definitely will impact to the accuracy of your georeferencing. So when you have collected 2 points, open the link table. Are there already any residuals calculated? Why or why not? So at first, let's open here is a view link table. Here you can find the ground control points we already noted, collected. So here's the first one, the second one. So here's X source and Y source, the inner coordinates of a ground control point. And here's X map and Y map, the outer external map coordinates of a master map. So it's actual real projected coordinate system, and this one X and Y is the inner coordinate system in rows and columns. So we can see here that there is no residual it measured. Why? Because for the first order polynomial transformation, we should at find collect 3 ground control points. So if we open here the transformation, see, it's not activated yet, because we should collect at least 3 ground control points, but it's preferable to collect at least 4 for the first order polynomial. So let's continue collecting. So I just prefer to choose from this place, right? You can collect your own control points, but just try to make them so see that ArcGIS already tries to find the error, because I I found the third ground control point close to each other, so it's not the case. Actually, it's not a problem. We can open the link table. Here is my third control point here. See, it's I can now just delete it. How? Though, with this button. So it's already deleted. And again, I should find another ground control point. I will try to, for instance, from this place, this one, and this one, right? So there is no error now, right, from the ArcGIS. So, and again, I will just try to distribute my measuring, and which place for probably this one, right? Fourth ground control point. See, so my overlay of both the slave map and the master map becoming more accurate, but you can see here the black colors. So anyway, during your georeferencing, you will see these black colors, and the higher the bigger the area of the black area, more or less precise your georeferencing will have. But anyway, you know, this is a big topic, and while you georeference your slave map to the master map, you should notice that it will not 100% correlate with each other, because there are many reasons for that, because they are in the slave map do not have coordinate system. It can, for instance, it can be just not drawn with you by hand, and also, or for instance, you took an aerial image, and aerial image can also be imaged. The image could be taken not accurately, etc. But anyway, do not be frightened with this black color. And now we can open the link table and see that our residuals are already started to measure. So residuals are errors, the deviation from the true and measured locations. So and here is root mean square error, which is the sum of all average of the residuals. And here's I have the 0.65 root mean square error. It's actually a very good result so far, because smaller your root mean square error, more accurate your georeferencing result will be. While collecting ground control points, try to always check your link table, and be sure that be confident that your root mean square error should be not bigger than 4, because if it's bigger than 4, there will be more, and it's not very big, but measurable distortions. So let's continue, and now we should collect again 8, right? 8 control points. So I just right here and this place. So which one? So see that this one and this one. 6 my control point. This one, this place. So I check again my control. So it's already 3, but it's so far it's okay. Anyway, when you measure, when you take more control points, right? For instance, 8, 10, you will have higher residual and bigger root mean square error. So taking more control points, you always increase your root mean square. So this one with this place, so where should I take again? I think I didn't measure for this one, right? So this place with this place, I need to collect 3 more. So this one with this one, I think. So I would collect 10, 3.3. Not bad actually for 10 control points, and I need 2 more. I think if I will zoom out, so I measured from these places, I didn't measure it here. So I close this one and this one. And I think I will take here, right? And I open again, so it's even smaller. So I just collected 12 ground control points. The question is, what total remass error did you achieve after collecting 12 control points? So I achieved very good result, 3.2. I already mentioned that you need maximum root mean square error 4. So try to achieve at maximum 4. A total remass error between 2 and 4 is acceptable. Save the control points, place the file in your workspace. So while you stop to collecting control points, do not forget please to save your control points, because try not to lose it, because you probably may need it in the future. So I will just 12 ground control points here. So I use this link, this button, save. So I already saved my 12 ground control points in the text format. And I can open again georeferencing transformation, see that first and second and third order polynomial is activated already. So I can make the first order polynomial because I have more than 3 ground control points. I can make 2 because I have more than 6, and even I can make 3 or third order polynomial transformation because I have already 12 ground control points. So replace control points with high residuals is necessary. So if you have very high residual ground control points, for instance here I have this one, right? I can delete it and measure it again. Okay, so measure it more accurately. So if you when you delete the points which have high residual, the total root mean square error reduces. So you can make more research in root mean square error. Its root mean square error is just indicates the accuracy of your measurements. So that's it. And the smaller the root mean square error you have, more correct, more precisely and more accurate your georeferencing output will be. So here I pause the video. And from the next video we will start rectification process.